Now let's just move on further towards the next theorem, which says that angles in the same segment of a circle are equal. So angles in the same segment of a circle are equal. We just need to prove this. So let us suppose if I'm just starting with the given condition. So let us, if I'm saying we have a circle with the center O and an arc PQ and an arc PQ subtending an angle at O, and the two angles PAQ and PBQ on the same segment of a circle. So this is actually a given condition that I am taking, and let us suppose if I'll draw as per my given condition that I am taking this circle and I'm taking the center as nothing but O. Again I'm taking PQ arc in such a manner that it is definitely subtending a particular angle at POQ. That is, suppose this I am just taking, and I am taking any other point A and B in the same segment of the circle in such a way that I am just taking this angle over here, and further I am just taking this angle PBQ over here. So what do we need to prove over here? So we need to prove that the angle PAQ is equal to the angle PBQ. So we need to prove that this angle is equal to this angle. So let us suppose if I'm just starting with the proof of this. Since the proof of this, so we can say that since the angle subtended by an arc at the center of the circle is double the angle subtended by it on any remaining point of the circle So as PQ arc is subtending an angle at the center and two remaining points on a circle, that is A and B. So using that concept, we can say that the angle POQ is actually twice of the angle PAQ using this theorem. And again we can say that POQ angle is nothing but twice of the angle PBQ. Let us suppose if I'm calling it as 1, I'm calling it as 2. By the theorem we can say that I have already written over there. By the theorem we can say, which is nothing but the theorem that I have already mentioned it over here. So what we can say from 1 and 2, we can say that the angle POQ is nothing but is equal to twice of angle PAQ, which is equal to twice of angle PBQ. So if I'm just taking these two only, so it implies that twice of angle POQ is equal to twice of angle PBQ. 2 and 2 get cancelled with each other, so we are getting PAQ is nothing but is equal to the angle PBQ. And this is exactly what we need to prove over here, that angles in the same segment of the circle are equal to each other. So this is nothing but all about this theorem.